Good morning, students. Today we discuss about Cauchy's integral formula. Statement is f of z is analytic function and z naught is any point lies inside the circle. Then f of z is equal 1 by 2 pi I integral c f of z by z minus z naught into dz. Here f of z is assumed analytic function in the region R. This is the region, simply connected region. But we multiply by a factor 1 by z minus z naught, that is analytic except at z naught, and consider the following integral around c, that is I is equal integral c f of z by z minus z naught dz. Here c is closed circle. Closed means starting and end points are same, and z naught is any point lies inside the circle. So to evaluate this thing, that path to a small circular path C naught as shown, that is integral C f of z by z minus z naught dz is equal integral C naught f of z by z minus z naught dz. Then we have to show that integral C f of z by z minus z naught dz is equal to 2 pi I into f of z naught. Consider small circle C naught, that C naught lies inside the circle C. Here Z naught is any point lies inside the circle. So consider Z minus Z naught is equal R into e power I theta. Differentiation this, we get dz is equal to Ri into e power I theta d theta. Substitute the value in small circle, that is integral C naught f of z by z minus z naught dz. Here z is equal, z value is equal z naught plus R into e power I theta. Substitute f of z is equal z minus z naught plus R into e power I theta. Here the small circle shrink, that means small, very small, that is R tends to 0. R tends to 0 means that is the limits integral 0 to 2 pi. R tends to 0 and we get this f of z dot plus R e power I theta is equal to f of z, and the limit points are 0 to 2 pi. And dz value is equal to Ri into e power I theta into d theta divided by z minus z naught is equal to R e power I theta, that is equal 2 pi I into integration of d theta is equal to theta, and the limits are 0 to 2 pi. Substitute these limits, we get 2 pi. That is f of z naught integral 0 to 2 pi Ri e power I theta d theta divided by R e power I theta is equal, here R e power I theta numerator part and denominator part are cancelled. We get 2 pi I into f of z naught. Here R tends to 0. That is integral C f of z by z minus z naught dz is equal 2 pi I into f of z naught. So we get Cauchy's integral formula f of z naught is equal 1 by 2 pi I into integral C f of z by z minus z naught dz. This is the Cauchy's integral formula. Here f of z is analytic function and z naught is any point lies inside the circle, where C is some simple and closed curves. Closed means starting and ending points are same. So this is the Cauchy's general formula, that is f nth derivative of z naught is equal to n factorial by 2 pi I integral C f of z by z minus z naught whole to the power of n plus 1 dz. Here f of is analytic in a region, and analytic means it is derivable at every point, And C is a simple closed curve. Z naught is any point lies inside the circle. We get the Cauchy's general formula is f nth derivative of Z naught is equal to n factorial by 2 pi I into integral C f of Z by Z minus Z naught whole to the power of n plus 1 dz. Thank you.